All right, this is going to be our walkthrough for the homework assignment titled Basic Integral Rules. We're just going to be evaluating each of these. I believe they're all indefinite integrals. No, I think we have some definite integrals at the end. So we're just going to be evaluating all these integrals using our basic rules for integration, sometimes doing a little bit of manipulation to simplify it first or put it into a form that's easy to integrate. So the integral of 3 dx, well, if we think about what function gives us 3 when we take its derivative, that would be 3x. So the integral of 3 should just be 3x, right? That's just using the power rule. It's 3x, and of course, plus some constant. And anytime it's an indefinite integral, don't forget plus c. For this one, we're just going to use our power rule for integrals. So we'll go up to 7x cubed, and then we'll divide by that new power of 3. So it's 7/3 x cubed. And the same here, the 5x will go up to 5x squared. And we'll divide by 2. And then the plus 1 just becomes plus x. And of course, don't forget your constant. For our next one here, we're going to do the exact same thing. We'll just go up to x to the 7/3, and we'll divide by 7/3. And then we'll do minus 2x to the 4/3, and we'll divide by 4/3, and then the plus 1 becomes a plus x. Don't forget the plus c. But we will rewrite this, right? We're not going to divide by 7/3. That's the same as multiplying by 3/7. So it's 3/7 x to the 7/3. And then the same thing there with the division by 4/3. We're not going to divide by 4/3. We'll multiply by 3/4. And when I do that to the 2, I get 6/4, which is 3/2. So minus 3/2 x to the 4/3 plus your x plus your constant. All right, for this one, we'll go up from 3x to the negative 2 to 3x to the negative 1, and then we'll divide by negative 1. And then on our integral rule sheet, the integral of secant squared is just tangent, right? Because the derivative of tangent is secant squared. So that's minus 5 tangent x, and then minus x plus your constant. And of course, we'd like to rewrite this as negative 3x to the negative 1, or probably just negative 3 over x, minus 5 tangent x minus x plus c. For this one, we'll first distribute this out. So that'll be x squared, and then a minus 3x and a plus 2x will just make a minus x, and then a minus 6. And when we integrate now, we'll just get x cubed over 3 minus x squared over 2 minus 6x, and of course, don't forget the plus c. For our next one here, it might be helpful to rewrite this one into a form that is a little easier to look at. It's just x to the negative 4 dx. So that should go up to x to the negative 3, and then we divide by negative 3 plus our constant. So this is just negative 1 over 3x cubed plus c. We're going to do a similar thing here. We'll rewrite this one as the integral of 3x to the negative 1/2. Right? And then we can just integrate that. Right? We go up from negative 1/2 by 1. That's 3x to the 1/2, and we'll divide by 1/2 plus your constant. And of course, multiplying by 2 is the same as dividing by half. So this will be 6x to the 1/2, or 6 root x, plus our constant. For our next one here, we'll want to distribute this out first. So this is going to be an integral of x to the 4/3 plus 5x to the 1/3. And so when we integrate x to the 4/3, that'll go up to become x to the 7/3. And then we'll divide by 7/3, which is the same as multiplying by 3/7. So you should really get used to just kind of doing that all in one step, right? 3/7 x to the 7/3. And then we'll go up to x to the 4/3, And when we divide by 4/3, that's like multiplying by 3/4. So that'll be plus 15/4 x to the 4/3. And of course, don't forget your plus c. All right, for our next one here, we're going to have to distribute all this out using the difference for a for a cube, not a difference of cubes, but just an a minus b cubed formula, right? So x squared cubed should give us x to the 6th, and right and like when we do a minus b cubed, right? I'll write it out down here. A minus b cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed, right? So this is x to the 6th, that's the a cubed, and then we have minus 3 times a squared times b. And so that's going to be minus a 3x to the 4th times a 2x, which is going to be minus a 6x to the 5th. And then the 3ab squared, right? Well, we're going to have a plus here, right? It's going to be a plus 3 times our a, which is x squared, so 3x squared, and then times 2x times 2x, that's going to be 12x to the 4th in the end there. And then minus b cubed, that'll be minus 8x cubed. Right? So we need to know how to distribute that all out. And now we'll just do our integration here using the power rule, and that'll become x to the 7th over 7 minus 6x to the 6th over 6, or just minus x to the 6th, and then plus 12/5 x to the 5th, and then that one would go up to x to the 4th and divide by 4, so that'll be minus 2 x to the 4th, and then of course plus our constant. For our next one here, what we want to do first is we want to just divide every term here by x squared. So x to the 4th over x squared is x squared. Minus 3x cubed over x squared is just minus 3x. Plus x over x squared is just a 1 over x. Right? And minus 1 over x squared is just minus an x to the negative 2. And I wrote the 1 over x as it is because normally we see that rule for the integral of 1 over x because we can't use the power rule on that one. And I wrote the other one as x to the negative 2 because that one normally we will use the power rule. And so as I integrate here, we get x cubed over 3 using the power rule, minus 3/2 x squared using the power rule. And then not using the power rule, the integral of x to the negative 1, or 1 over x, is just the natural log of the absolute value of x. And then the integral of negative x to the negative 2, right? Well, we should go up to negative 1 and divide by negative 1. So we end up with a plus x to the negative 1, or plus 1 over x. And of course, don't forget the plus c at the end. All right, for our next one here, we're going to do the same idea, same process here. We're going to rewrite this as an integral of 1 over x, because that's what x cubed over x to the 4th is. And then minus 5x to the negative 3. And then plus x to the negative 4. And we will integrate all of those to get the natural log of the absolute value of x. And then if we go up to negative 4 and then up to negative 2, and then divide by negative 2, we're going to get a 5 over 2 x to the negative 2, which will be 5 over 2x squared, or 5/2 x to the negative 2. And then we'll go up to x to the negative 3 and divide by negative 3. So that'll be a minus 1 over 3x cubed. And then, of course, plus your constant. Right? All right, for our next one here, we should just recognize that the integral of secant squared is tangent. That's on our formula sheet, right? Because the derivative of tangent is secant squared. And then the integral of negative x should just be minus x squared over 2. And the derivative of minus 1 should just be minus x. And of course, don't forget your constant. And again here, we're going to just divide everything by that cosine squared. So this becomes an integral of just cosine x plus 4 over cosine squared, which is 4 secant squared x. And the integral of cosine is just sine, right? Because the derivative of sine is cosine. And then the integral of 4 secant squared x is just 4 tangent of x. And of course, after doing all that division and thinking about the trig, don't forget also the plus c. All right, for our next one here, we've got the secant of x times 1 plus sine of x over cosine of x. And so that's clearly not in like a nice, easy to integrate form. So let's see what we can do with this. Let's leave the secant as it is, and then figure out what's going on with the stuff inside the parentheses. 1 over cosine would just be secant, and sine over cosine would be tangent. And so if I were to distribute that out, I'd get an integral of secant squared x plus secant x tangent x. And we should see that those are both really nice and easy to integrate, right? The integral of secant squared is just tangent, and the integral of secant tangent is just secant. They're both from our formula sheet, right? And don't forget the plus c, right? And we know that the derivative of tangent is secant squared, right? And the derivative of secant is secant tangent, so the integrals should work out just like that. All right, here we got 2 sine 2x over cosine x. Another one that's going to need to be manipulated. So we'll use the double angle identity, right? That sine 2x is the same as 2 sine x cosine x. And now I can cancel out those cosines, and I really am just looking at the integral of 4 sine x dx. Well, the integral of sine x is negative cosine x, so this should just be negative 4 cosine x. Plus, of course, our constant. All right, for our next one here, this is our first definite integral. So we're going to just integrate the function, and then we'll evaluate it at 3 and evaluate it at 0 and find the difference. So this will just be x cubed over 3 minus 3x using the power rule, and we'll evaluate from 0 to 3. So that ends up being 3 cubed over 3 minus 3 times 3 minus 0 cubed over 3 minus 3 times 0. Might as well make those match up. We'll make that a parenthesis also. So 3 cubed is 27. 27 divided by 3 is 9. So we got 9 minus 9 minus, well, that's all just a bunch of 0. We just end up with 0 for this first one. For this next definite integral, we'll just integrate sine plus cosine, right? The integral of sine is negative cosine, and the integral of cosine is positive sine. And we want to evaluate this from pi over 4 to pi over 2. So we've got the negative cosine, I'll write this out, the negative cosine of pi over 2 plus the sine of pi over 2 minus the negative cosine of pi over 4 plus the sine of pi over 4. And so the cosine of pi over 2 is just 0. So negative 0 is just 0. So we have 0. And then plus the sine of pi over 2 is 1. And then minus. And then the negative cosine of pi over 4 is negative root 2 over 2. And sine of pi over 4 is root 2 over 2. So those are going to cancel out. And we end up with just 0 plus 1 minus 0, which is just 1. Now this one might look difficult at first, but it's actually exceptionally simple. right, we recognize that sine squared plus cosine squared is just equal to 1. So this is really just the integral from 1 to 5 of 1. Well, the integral of 1 is just x. This is x evaluated from 1 to 5. That'd be 5 minus 1, which is just 4. All right, here we've got the integral from 0 to pi over 4 of 5 plus 5 tangent squared x. Well, this is actually kind of similar to the last one, that we could rewrite this as the integral from 0 to pi over 4 of 5 times 1 plus tangent squared x dx. And 1 plus tangent squared x is just the same thing as secant squared x, right? That's just another Pythagorean trig identity. So I'll take that 5 outside the integral, and now I have 5 times the integral from 0 to pi over 4 of secant squared x dx, which is just 5 times, well, the integral of secant is tangent, and we'll evaluate from 0 to pi over 4. So this is 5 times the tangent of pi over 4 minus the tangent of 0. The tangent of pi over 4 is just 1. And the tangent of 0 is 0. And so we just have 5. And for our last one here, we'll just find the integral and then evaluate it on that interval. So the integral of e to the x is just e to the x, and the integral of 1 is just x. So we have e to the x plus x from 0 to the natural log of 2. Well, that'll become e to the natural log of 2 plus the natural log of 2 minus e to the 0 plus 0. Well, e to the natural log of 2 is 2. The natural log of 2 is just 2. And then we have minus e to the 0, which is 1, and then the 0 goes away. So 2 minus 1 is just 1. We end up with 1 plus the natural log of 2. And that is the end of this basic integrals homework assignment.